Hi guys, so this is from Module 4 study guide for lines and angles. So if you're looking at number 1, basically we have two parallel lines. Okay, we have line M and N. Sweet. All right, so they're parallel. Therefore, we're going to use certain theorems to identify certain congruencies or something along the other lines of those theorems. So if you look at the first one, part A, using corresponding angles. So corresponding angles theorem. So angle 1 is congruent to angle 5. Okay, those guys are congruent or corresponding angles. Now angle 2 is congruent or corresponding to angle 6. Let's see, angle 3 is corresponding to angle 7. And angle 4 is corresponding to angle 8. Okay, so that's what they're talking about for part A. All right, so looking at part B, they're asking about alternate interior angles. All right, for that theorem. So let's look. Angle 3 is definitely going to be an alternate interior to angle 5. So you would say angle 3 is congruent to angle 5. And we have angle 6 here, and he's congruent to angle 4. So angle 4 is congruent to angle 6. You could say it either way. Angle 6 is congruent to angle 4, or angle 4 is congruent to angle 6. Either way works, but those are alternate interior angles. All right, so let's look at part C. Using same side interior angle postulate. They also call it consecutive, just in case you ever see that word, but we call it the same side interior angles. Let's see, 4 and 5 are on the same side and they're interior, so angle 4 is not congruent to angle 5, not necessarily. The angle 4 plus angle 5 are supplementary, therefore they add up to 180. There we go, 180 degrees. All right, so angle 3 and 6 are also same side. So angle 3 plus angle 6 should also be 180. Okay, they are supplementary angles. Okay, not like corresponding and alternate interior. Okay, those guys are congruent to each other, but same side are not congruent. They are supplementary. They should always add up to 180. All right, so moving on to part D, alternate exterior angle theorem. That would mean angle 1 and 7. They alternate, but they're on the outside of your parallel lines. So angle 1 is congruent to angle 7. And then we have angle 2 to angle 8. And those two are going to be congruent. All right, so we're going to use the same diagram, I think, for number 2. And basically they're saying, well, if angle 5 is 62 degrees, and let me clean this up. Angle 5 is 62 degrees. All right, right here. What other angle measures 62 degrees? Why? Okay, well, let's see. Angle 7 is a vertical angle. Therefore, he's also going to be congruent to angle 5. That means he's also 62 degrees. And again, that's because he's vertical angle. Who else? Let's see. We have our alternate interior angle. So who's an alternate interior angle of 5? 3, right? So angle 3. That's again because of alternate interior angles. And who else? Who else? Who else? What about the corresponding, right? Angle 1. So angle 1, and again, that's because of corresponding angle theorem. Any others? Any others? If you see any, let me know. Okay. but I think for the most part, I think I knocked it out of the park. Yeah. All right, number 3. It looks like we're using the same diagram, the same picture. So I'll tell you what. I want you guys to test yourself. All right. So number 3 is definitely for you for homework. All right. Same process as number 2. Okay. And again, you're using this diagram. Okay. All right. So looking at number 4, which statements must be true? Why? Okay. Well, they say that angle 1 plus angle 3 equals 180. Okay. Well, we know this guy and this guy are vertical angles, right? Therefore, angle 1 has to be congruent or the same as the measure for angle 3. But wait a minute, that means, well, angle 1 is angle 3 and angle 3 is angle 1. They're the same. And the only two sums of degrees that are the same that add up to 180 can only be the 90s. 90 plus 90, right? Same. And they add up to 180. And that makes sense because they're vertical angles, right? So notice how the vertical angles kind of kicks in, and then it helps you kind of guide the algebra. We have two of the same angles, okay, equaling 180. So you have the division property. That means your angles are 90 degrees, both of them. Okay, which makes sense because you have vertical angles. Now, which statement must be true? Line L and M are perpendicular. That is definitely going to have to be true. Okay, because again, 90, 90, right? And since this guy's a linear pair, angle 3 is a linear pair to angle 2, he's also 90. And by vertical angles, angle 2 is congruent to angle 4, therefore they're both 90s. So yeah, they're all perpendicular. Now, are they parallel? No. Okay, obviously those lines are crossing one another. Angle 2 is 60 degrees or less than 60 degrees? No. Is angle 3 greater than 90 degrees? No. Equal, but not greater. Okay, and why? Is again vertical angles. All right, number 5. So based on the following figure, let's answer these questions. All right, value of x. First things first, notice here how they just throw in this expression with x, this expression with x, and then this expression and this expression. Let's work with something we got, okay? So they're throwing out a lot of expressions that have x, but let's figure out what's what. Well, aren't these two angles vertical angles? So let's use that, okay? We have 6x minus 16 degrees, okay, equaling 2x plus 4. And I should have started off by saying angle BPA, BPA is congruent to angle EP, or we could say KPE, okay? And again, that's vertical angle theorem. And then the rest is just algebra, okay? So we use the subtraction property. What we do to one side, do the other. Addition property, what we do to one side, do to the other. We get 4x equaling 20. Division property, and we get x equals 5. Awesome. So what is the measure of the angle KPE? Well, we just found the value of x, so let's just substitute it back in. So if you remember, angle KPE equals 2x plus 4. We just said that x is 5, so let's just substitute it back in. So we have 2 times 5 plus the 4. That's 10 plus 4, which is 14. Oops, my mind is going a little faster than my hand. There we go. Again, 10 plus 4. So angle KPE equals 14 degrees. Nice. All right, so number 6, they're using parallel lines. What is the value of x? Okay, I'll tell you what. Well, here's the expression with x, and he's representing this angle. And isn't 103 going to be an alternate exterior angle? So therefore, okay, so by alternate exterior angles, all right, by that theorem, we know that 7x minus 2 should be congruent or equal to that 103 degrees. So I'll tell you what, the rest is on you. Go ahead and finish that one for me. Go ahead and solve for x, okay? All right, number 7, based on the figure below, state whether the conditions are true or false. C and F are complementary angles. C and F are complementary angles. That means that they add up to 90 degrees. So that lines G and T are parallel. Well, that's false. Okay, C and F need to be congruent, not complementary. Okay, if it said congruent, then yeah. All right, but it didn't. It said complementary. All right, which means again they add up to 90 degrees. All right, since D and F are supplementary, so let's see, D and F are supplementary. That means they add up to 180 degrees. G and T are parallel. That is true. Remember, same side angles add up to 180, okay, because they're same side. So that's something to notice. Angles D and E are supplementary. Let's see, D, let me clean this up a bit. D and E are supplementary. That means they add up to 180, but in this situation, it doesn't look like they're both 90s, so I'm going to say false. Okay, if the transversal, okay, again, the transversal cutting through the two parallel lines was perpendicular, that means 90 degrees, then yeah, it would be true, but it looks like it's not. All right, lines G and T are parallel because C and F are congruent. Okay, C and F are what kind of angles? If you answered alternate interior, you are correct. And yes, that is true. Okay, alternate interior angles. Okay, they have to be congruent, and then therefore they're parallel, G and T. All right, number 8, the diagram shows the point. So this is along the whole idea of finding the other side of your triangle. Okay, we've done this with equidistance for perpendicular bisectors. All right, so find RA. RA, even though there's not a line there, there's an imaginary line. Okay, you have a right triangle because this is a perpendicular bisector. Okay, it says right here of AB. So we're going to go ahead and use Pythagorean theorem. Okay, which basically is going to get you the square root of 7 squared plus 6 squared. So that gives you 49 plus 36, 84. I think I'm doing quick math in my head. See, that's 49, 9 plus that, 85, there we go. So square root of 85. Okay, so that's what you should have gotten. And remember, I'm using Pythagorean here, okay? So you would say raw squared equals 6 squared or 7 squared, okay? And that's ultimately what happens is I square root both sides to get rid of that square on raw, and then that's how I get down here, okay? RB, again, is the same as RA. If you look, I'm trying to find this guy right here, right? 3 plus 4 is 7, so you're using the same side. So you should be getting the same situation as with raw. Okay. TR. All right, so TR, let me clean this up. TR is right here, okay? Again, we're still using a right triangle, so I'll tell you what, go ahead and try TR for homework, okay? Same process, use Pythagorean, test it out, see how far you can get. Again, you should have the square root of something squared plus something squared, and you should get something squared. Okay, so try that one out. TS, I'll go ahead and do that one for you. TS is right here. Again, we're dealing with this triangle, which is basically 3 squared plus 3 squared. Good old Pythagorean. And that should be 9 plus 9, which is the square root of 18. Good. Nice. AS is right here. Notice how I'm creating the line that doesn't exist because I'm still really just triangulation, right? I'm just finding the hypotenuse using Pythagorean. Okay, and you should get, again, here's one side, here's your other side. So we got 7 squared plus 3 squared. Let me clean that up for you. Which equals 49 plus 9. So we got 58. Square root of 58. All right. And BS, don't BS me. I want you to do that one for yourself. Okay. Again, see what your sides are. Use Pythagorean. Don't forget this is 3 plus 4 over here. And I want you to do that one for homework. Don't BS me. All right, number 9. Determine whether each pair of lines are parallel, perpendicular, or neither. Select the correct answer for each lettered part. Okay. So if I rewrote this guy from standard form to slope-intercept form, he should look like this. I want to subtract the x, divide by the -2, and I should get negative, actually that's a positive, 1/2 x, and then division by that is a negative that. Okay, so this slope right here is 1/2, while this slope is 1. That is definitely not an opposite reciprocal, right? And it's not the same slope. So it's not parallel, it's not perpendicular, it's neither, okay? If we test out the next one, okay, it looks like, again, I'm going to rewrite this standard form equation to slope-intercept. So I'm going to have y equals, this is definitely going to be -1/5 x plus 8. And if you notice, the slope here compared to this guy's slope is the opposite reciprocal. Therefore, it has to be perpendicular. Okay, so again, same slope, parallel. And the opposite reciprocal, perpendicular. If neither of those happen, it's neither. So I want you together with your group, I want you guys to solve those 3 on your own for homework. Okay, get your practice in. Of course, you do have to change and rewrite some of these equations back into slope-intercept form. Don't forget to divide the 3 here on this one, for example, right? And look at their slopes. So this is all homework for C, D, and E. Okay. Parallel, let me see real quick if I can find a parallel one just by scanning it real quick. Ooh, okay. Yep. All right. So I'll tell you what, I'll do D. Okay. E you still have to do for homework, sorry. Get your practice. All right. If I rewrote this guy, okay, right here, I would get subtraction of 15x, division by -5, and I end up getting y equals 3x, and then 5 divided by 10 divided by -5 is -2. What do you notice about the slopes? They're the same, right? So since the slopes are the same, this one's parallel. Okay, so that's the example of parallelism. Try part C and E on your own, or with your group. All right, number 10. Which of the following equations are perpendicular to the line of this and passes through the point of here? So we got an x value and a y value. This is going to be point slope. So we have y minus whatever y value they give us equaling the slope times x minus whatever x they gave us, okay? So here's the x they gave us, here's the y they gave us, and we're just going to use point slope. Now, they want us to be perpendicular to this guy. That means we have to use the opposite reciprocal, which means that we flip, right? And negate. Negative of a negative is a positive, therefore our slope has to be 4/3 because they want it to be perpendicular. Okay, so y minus which y? The one they gave us, -5, right? From over here. Equals our slope, which again is going to be 4/3, times x minus the x value that they want, which is 12. Y minus a -5 is really just y plus 5, equaling 4/3 times x minus 12. If I go ahead and rewrite this, I'm going to distribute the 4/3 to everything inside my parentheses. I'm going to get y plus 5 equaling 4/3 x. The -12 times the +4 is a -48, right? And then -48 divided by 3, you should get -1, carry the 1, 6. So we have -16. Let's use the subtraction property to get rid of the 5. What you do on one side, do the other. And we have y equals 4/3 x. -16 minus 5 is -21. And the only one that looks like that is this guy right here. Okay. All right, so let's see. Given the points, this guy and this guy, determine whether the lines that contain the points are parallel or perpendicular to this guy and this guy. Oh, okay. So this is actually just slope formula. Second y minus first y all over second x minus first x. And then you're going to use it for two different equations. So let's see. First one, we'll do this one. Let me color code them here. We'll do the red guy first. All right. So red guy, again, this is the first point. So those are the first values, the first x and the first y. Second value, second point, which means second values, x sub 2, y sub 2. All right, so y sub 2 is -13 minus the first y, which is a -7. Notice I'm using the parentheses to make sure the double negative is understood. And then we have our second x minus our first x. -13 plus 7, right, is basically going to be -6. And 12 minus 2 is 10. We can reduce -3/5. Okay, let's try the other guy. So let me pick a nice color, purple. There we go. This guy and this guy. Okay, this is my first x, my first y, my second x, my second y. All right. So my first y was 3 minus my first y, which is 6, and then my second x, which is -5, minus my first x, which is -10. Oh, so I'm paying attention to the double negatives. All right, I get -3 on the numerator. -5 plus 10 is +5. Oh, look at that. What do we know? They're the same. All right, therefore we got to be parallel. All right, do the same thing for homework for number 12. It's just like number 11, but who knows about the answer, okay? Same thing, just use a slope formula back in algebra. All right, determine whether the lines are parallel or perpendicular to each other. Okay, so number 13, it's in standard form. We could rewrite it, right? So let's move over the 3x to both sides, right? And then we're gonna have to divide both sides by -5. So if we do that, you're gonna have y equals negative, here, let me go ahead and show you the whole process just in case algebra 1 is so long ago. Let's make sure you're okay on that one. All right, so we have 3x minus 5y equals 10, okay? Subtract the 3x. Again, we're just rewriting this into slope-intercept form. So we're going to have -5y equaling -3x plus the 10. Division property, right, of both sides. we're going to get y equals negative, but divided by negative is a positive, so we have positive 3/5 x, and 10 divided by negative 5 is negative 2. So there's that guy right there. Okay, let's go ahead and try the guy right here, the purple one. We have 10x plus 6y equaling 40. Again, subtraction property, let's move over the term with the x variable. We're going to have 6y equaling negative 10x plus 40. Division property, what you do to one side, do the other. So we're going to have y equals, looks like we have to reduce by 2's, so we have negative 5/3 x, and 40 divided by 6 is, again, it looks like it's going to be left as an improper fraction. Can we reduce? Yeah, I think we reduce, so we have 20/3. Okay, what do you guys notice about the slopes? They are opposite reciprocals. One of them flipped and negated, so therefore these guys are perpendicular. Okay. Number 14 is just like number 13, so definitely get your practice in. This is homework. Okay. All right, we're coming up towards the end here. Number 15, let's see, angle 5 is 70 degrees. Angle 4 is going to equal what? So let's see, angle 5 is 70 degrees. Then angle 4, well, let's see, angle 4. Well, isn't 2 vertical angle, right? And also, if you think about line M and N being parallel, angle 4 is going to be congruent to angle 5. So that's going to be 70 degrees because of alternate exterior angle or angles theorem. Okay. So angle 4, you could also be like, well, angle 5 is vertical angle to angle 2, and angle 2 has to be the same as angle 4 because of corresponding angles. So there's several ways you can go about it with the logic. All right, part B. Again, use the same figure that I'm using and test it out. See how far you can get, okay? And then don't forget the reasoning. Why? What theorem, what postulate are you using? Okay, so again, part B is homework. 16. All right, so Mark is asked to prove that angle 4 and angle 6 are congruent, and he's given that these guys are parallel, okay? And then ask what reason supports the statement Mark made in step 2 for his work. Okay, so here's step 2, and he's saying that angle 8 has to be congruent to angle 6. Therefore, angle 6 equals angle. Okay, so what kind of angles, what kind of postulate you think, or what theorem do you think he's using? So let's see, vertical angles are congruent. Yep, those are vertical angles. Supplementary angles are congruent. Supplementary don't necessarily have to be congruent, so that's kind of iffy. Only if they were 90 degrees for sure, right? Corresponding angles formed by parallel lines are congruent. These were not corresponding. These were vertical angles. Okay, 6 and 8 are vertical angles. Alternate interior? Nope. These guys do not alternate. They are vertical. Okay. All right, 17. The proof of the following shows alternate interior angles are congruent when two parallel lines are cut by a transversal. All right, so they say R and S are parallel lines cut by a transversal. That was given. Therefore, angle 1 equals angle 6. And that is actually because of vertical angles, right? All right, so that was for step 2, this part right here for part A. Part B, which is the missing reason for step 3. Okay, angles 1 is going to be congruent to angle 3, and that's actually because of corresponding angles. All right, and again, that's the postulate or theorem. For some reason, I can't remember the difference right now. I'm tired. It's late. All right. So there we go. Vertical angles are congruent. So this one is actually straight out of, I think, your homework. I want you guys to see what we got here. We got angle 1 equals angle 2. And we're trying to prove that angle 1 equals angle 2. We're trying to prove that this guy is this guy, okay, that they are the same, okay? We're actually proving the vertical angle postulate right now, okay? So, angle M and N intersect at a point that's given. Angle 1 and 3 are linear pairs, that's right. All right, these guys share 180 degrees, okay? Um, angle 2 and 3 are supplementary angles, so if you add up angle 2 with angle 3, it should also be 90 degrees. So, you could say that since they're supplementary, they both add up to 180. So therefore, angle 1 plus angle 3 equals angle 2, or actually I should say equals 80, 180. It looks like we don't have that. And lo and behold, angle 2 plus angle 3 also add up to 180. Therefore, they equal each other. So angle 1 plus 3, angle 3, sorry, equals angle 2 plus angle 3. We can actually just subtract out the 3's and we get down to line 6. Now, this is the definition of supplementary angles. And that's how we were able to get the 180, and that's how we were able to get those two angles equaling one another. And then we were able to use the subtraction property, right, to get rid of that angle 3 on both sides. Okay, guys, so that was it. If you have any questions, let me know. Definitely try some of those homework problems that I just gave you for your study guide. We're also going to have homework and notebooks due, so just let me know if you have any questions. Our test in a couple days, all right? All right, guys, have a great day. Thank you.